All right, everybody. So we're here, March 24th, to go through this next section of Math 3. I need to give you a few just updates before we get started. So let me just go through a couple things. This should probably only be about, hopefully we'll get through this in about 30 minutes today, and we'll move on to the next topic. I think this is going to be a fairly easy topic just because you've done some of this before, but if not, we'll take our time and go back through it. If you have any questions on some earlier topics, we can do that too as you go through. Just a reminder, if you find some people, if you know a friend or anybody that was in class that has not gotten on to these meetings, is not able to or is not known about it on Zoom or anything, please make sure that they have the ability to get in here and get on these meetings. So first thing I'm going to do is I'm going to share my screen with you. If you look at this, this is the Canvas weekly schedule. So in order to take attendance, and that's coming up soon. So if you didn't know, yesterday you saw the governor passed or went through his executive order, which is going to keep us out until at least May 18th, which takes us to the last week or so of school. So in order to take attendance and kind of see who's working through the material, you are going to have to complete the work, obviously, but the way of taking attendance is going to be making sure you log into Canvas each day. That's what they want you to do. So even if you feel like you don't need to log into Canvas, you do. So I do want you to log into Canvas each day, and I will post the stuff there. If you notice, this is the link for the video from yesterday. So yesterday's work is up there and the link to our video, and then I'll post the video from today and so on. I'm also using the Canvas Messenger to send you the links for the next day's Zoom video so you can get to it. But the way I look at that is on my screen, it's not visible to you, but I can click on people. And this basically gives me, and I'm showing you what I see, this gives me every student in the class and the last time they logged on. So you want the last time, so I can see everybody. So if I was going to take attendance for today, it would be March 24th. I would go ahead and say, okay, Caroline has logged on for March 24th. Christopher has logged on for March 24th. And so on, and I would take attendance, and I would do that at the end of the day. So make sure at some point during the day, it doesn't have to be now it's okay, but at some point during the day you want to make sure you've logged on to Canvas, and that way I can kind of check you off and say, okay, they've come on to that, and so they don't have any problem there. So if anybody has any issue with that, make sure that you're doing that and that you're just using the announcements. The announcements are where we're going to have most of the material, and then you'll be able to kind of submit the whole packet. Either you can either turn it in, or we'll probably end up just submitting it on Canvas. That'll be the easiest way to do it all at once when we finish this Unit 6 is kind of the scenario, or kind of where we're going right now. Okay, so that puts us at, today is Tuesday, so 6.4 is solving polynomials. So if you'll get your notes for 6.4, I'm going to pull it up. It should be right here, solving polynomials. Is everybody ready to go in the chat? Can everybody hear me and be at the right spot? Everybody has this paper. Thank you. Okay, awesome. Thanks, guys. If you have a question as we're going through this, you can ask it in the chat, and I may just keep going, and then I'll come back to it. But at any time that I'm talking through this, make sure that you can post a question in there, and it does show up on my screen. I'm able to kind of see what your question is. All right, so today's lesson is solving polynomials. And basically, there's something called, and again, it's called the fundamental theorem of algebra. in order to find the factors and the roots. So if you remember, factors and roots and zeros and x-intercepts, those are all the same thing. So when we talk about a factor or a root or a zero or an x-intercept, we're talking about the same thing. We're talking about solving the polynomial. We're talking about where it crosses the x-axis if we're looking at a graph. We're talking about what makes it equal to zero. We're talking about an equation. That is the things we're talking about here. So example number 1 says, write everything you know about the following polynomial. So does anyone know what degree this polynomial would be? If you think you do, you can just type your yes in the chat. What degree would that polynomial be? You can take a guess. Anybody wants to take a guess? Cool. All right. Anyways, now let's go to Desmos real quick and let's look. A degree of 1 is a line. It's linear, okay? It's a degree of 1, x to the 1. A degree of 2 is a quadratic, which is a U shape, right? A degree of 3, let me pull the other two off, is where it is turn and then another turn. So let's take a look. We go back to our notes. This one is a degree of 3. And I will tell you, there is a way of knowing that. When you look at it, first of all, it is ending in opposite directions. So that tells me that it has to be an odd degree. So because it's ending in opposite directions, so the end behavior is opposite, and I'm going to write that in the chat. The end behavior is opposite. So that means it is an odd degree. Okay. And then if you look on here, I can tell you how many turns it has. So you see where it changes direction down here at the bottom, that is a turn. And then up here at the top, when it changes direction, that's a turn. So the degree is usually, you look at how many turns you have, and your degree is one more than that. So if it has 2 turns, then it is the third degree. If it had 1 turn, like a U, think about that, it's a second degree. If it has no turns at all, like a line just keeps going forever and ever, then that is the first degree. So because this one has 2 turns, because it's going in opposite directions, it is a third degree. And again, you can look at that. It kind of goes with what we did yesterday, that the end behavior for odd equations is opposite. It's going from negative infinity. So to the left, this would be going to positive infinity, and to the right, this would be going to negative infinity. Okay, so that's a lot of things that we know about the polynomial. A couple other things. Where does this, so some things you know about the polynomial, where does it cross the x-axis? Where does it cross the x-axis? That's the y. So you got the, so you have the y-intercept. So the y-intercept is 6. Where does it cross the x-axis? So we got -1, we got -3, and we got 2. Yes. So those are the 3. A lot of times you also notice if it is a third degree polynomial, you will have up to 3 answers or 3 zeros or 3 roots. And that is, again, something else that we know about the polynomial. So you would want to write that in example 1 and write in that -3, -1, and 2 are the zeros or the x-intercepts. Told us that 6 was the y-intercept. That's good also. We know the end behavior. We know as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity to the right, y goes to negative infinity. We know the degree of this polynomial. It's the third degree. Those are all things we know about this polynomial. All right. Now it says highlight the values of importance. All that's saying is to, on your graph, if you'll just do like me here and just kind of highlight these, and I'll draw it. If you'll highlight the 6 is very important, so you want to circle that. That's our y-intercept. This is an important part here because that's one of our zeros, -1. This is important, that's -3. And then this also is important here, that's +2. If you want to make sure you highlight or just circle the important parts of this, it's also important, obviously, the end behavior, that it's going to positive infinity and to negative infinity. So those are all important things of this graph that we want to make sure we have and that will be used. And then we're going to move down. Okay, I'm going to erase all this. All right, so moving down to example number 2. I'm going to kind of take you through this kind of slowly. Example number 2, what we are doing here in part A is we are going to factor this, but we're going to factor by grouping. So I know that was an earlier topic before we got on Zoom, and I want to make sure that we actually get that topic. So I'm going to kind of talk about it and write a little bit on this. So factoring by grouping means we're going to take this first 2 things and we're going to take these last 2 terms and we're going to factor them. So what we try to do in factoring first, does anybody know what step 1 of factoring is? What would be the very first thing we would want to do? It's 3 letters. There you go, Smith. Thank you, Smith. So GCF. So we're going to pull out the GCF, or the greatest common factor. So if we're just looking at the variables, it's going to be the biggest exponent that they both have. So this is x to the third and this is x squared. So x squared is our GCF. So we're able to pull that out of these 2 expressions. And then what is left? So x to the third divided by x squared leaves us with just 1x. And 3x squared divided by x squared leaves us with +3. So we just write what is left in parentheses. Okay, so we did that for our first 2. For our next 2, we're able to pull out the GCF between -4 and -12. It is -4. So -12 goes into -4 evenly also. So we pull out the -4, and -4x divided by -4 is just x, and -12 divided by -4 is +3. And when we factor by grouping, look what happens. X plus 3 and x plus 3, they're exactly the same, okay, in parentheses. So the second part of factoring by grouping is you take what's outside of parentheses and you put that together. So that's x squared minus 4. You take what's inside of the parentheses, and you only have to write it 1 time. That's x plus 3. So now we have our 2 factors, or our 2, sets of parentheses. Now, x squared minus 4, if you want to know what that is, x squared minus 4 is x plus 2 and x minus 2 if we factor it. If you remember, x squared minus 4 is called a difference of squares, which means you would say a plus b and a minus b. So you would say x plus, so you would say, what's the square root of 4? We would say that's 2. So you would say x plus 2 and x minus 2. And then we just write down the x plus 3. So those are our factors, x minus 2, x plus 2, and x plus 3. Those are our factors. Those are our, almost called our answers. Now our roots are when we set these equal to 0. So if you notice, I'm setting all 3 of these equal to 0. And if I solve them, I would add 2. So my first root is 2. I would subtract 2 here. So my second root is -2. and I would subtract 3 here. So my third root is negative 3. So my roots are 2, negative 2, and negative 3. Okay, now we want to see how, how that looks on a graph. So at this point, I'm going to use Desmos, and we're going to go through what would that look like on a graph. So we have, we can take the original equation and we can graph it. And so it's x to the third plus 3x squared minus 4x minus 12. So I'm going to go there. X to the third. I got to go back. Plus 3x squared minus 4x minus 12. And there we can see our equation. If we need to zoom out a little bit, we can. But notice the things I want to click on is where it crosses the x-axis. Those are, so negative 3, negative 2, and 2. If I go back, those are our 3 roots. So could I have gotten the 3 roots without solving the equation? Yes. Okay. So could I have just typed this equation into Desmos, got the graph, then once I got the graph, found these are the 3 roots, so almost working backwards, negative 3, negative 2, and 2. And then if I know the root is 2, the factor is the opposite, x minus 2. If I know the root is negative 2, the factor is x plus 2. If I know the root is negative 3, the factor is x plus 3. So you see how I could have done this backwards. Everybody see how Desmos is really going to help us out in this situation. Now, could you find the factors like you find the roots? So if I'm graphing it, I want to, I would find the roots first, and then, yes, the factors are just the opposite. So if I know it crosses at 2, the factor is x minus 2. If I know it crosses at negative 2, the factor is x plus 2. And if I know it crosses at negative 3, the answer is x plus 3. Yes, Desmos helps us a lot. Now, the other thing on our graph that we want to make sure we have correctly when we graph it is what is the highest point and the lowest point, and it will tell us that also. So notice our maximum is somewhere around negative 2.5 and 1.1. So as long as you're close, it's fine. And then it will show you your minimum down here is like negative 13 or something. It also shows you your y-intercept, as we pointed out in the last one. So all the important points you can just click on, and Desmos will give you those. And then when we go back to try to graph it, they're not asking you to be super specific here, if you notice. So these don't hit at the right exact point that Desmos gives us. But what they are showing us is when we graph it, they want you to show the shape. So the shape of it is it's going up, then back down, then up. It's a cubic. So you want to see the shape of it, and then you also want to see where it crosses. So if you notice, negative 3, negative 2, and positive 2. So I want you to mark that on your graph as well. Okay, anybody got a question there on example 2? All right, I'm going to keep moving. So let me erase some of this that I annotated here, and we'll move on to part B and C of example 2 and D. It goes it goes a lot further. I'm only going to ask you, I'm going to let you mark off example C and D there. So if you want to just mark those off on page 1, and then we're going to mark off a couple on page 2 also. So if you'll cancel out C and D from the first page, we're not going to go through those 2 just because we'll already have 2 full examples, okay, for time. So mark off C and D in example 2. Okay, so let's go to part B. And part B is where we get an imaginary number, so we're all going to be excited here, so it's not fun. Okay, now here's the issue. So in part B, we want to do the same thing. So we're going to do grouping. So we're going to group the first two, and we're going to group the last two. Now, in the first two, you notice it's x to the third minus 3x squared. It's very similar to our first one in A. The GCF of these two is just x squared. So they both have at least two x's. So we're able to take out two x's, x squared. X to the third divided by x squared is x. Negative 3x squared divided by x squared is negative 3. Now, x and negative 3, what their GCF is nothing. They don't have anything in common. So we put a 1. So a 1. It's a positive 1, actually. But we put a 1 out there because they don't have anything in common. So it's just 1. And x divided by 1 is x. And negative 3 divided by 1 is negative 3. So it's just like we're rewriting it. So if they don't have a GCF, it's just like rewriting it. You just put a 1 on the outside. So now we have our two sets of parentheses, x squared plus 1 and x minus 3. Now let's look at x minus 3 first, because that's the easier one to deal with. X minus 3 is one of our factors, so we write it over here. And if we say x minus 3 equals 0, then our root is going to be 3, which means it crosses the x-axis at 3. So everybody sees the 3. Is that clear? I think that's the 3 part is the easiest. Now, x squared plus 1. That's the one where we're going to have a little bit of an issue there. So in x squared plus 1, let me kind of shift gears for a second, and I'm going to change to the whiteboard, and I'm going to get rid of this text here. Well, maybe it's fine. I will. I'm going to clear my drawings. So on the whiteboard, let's say that x squared plus 1 equals 0. Step 1 would be to subtract 1. So x squared equals negative 1. And step 2 would be to take the square root. So x equals plus or minus, because when we take the square root, remember, like if we're saying the square root of 4, 2 squared could be 4, but negative 2 squared could also be 4. So we always put plus or minus when we take the square root. So plus or minus the square root of negative 1. What happens when you try to take the square root of negative 1? Yeah, your calculator says error. So it will not, you cannot take the square root of a negative number. Okay, so you cannot take the square root of a negative. So it is called, when we have a negative square root, it's actually called an imaginary number. Okay, so the square root of negative 1 is actually plus or minus. To get a negative out of a square root, it is called I. I stands for an imaginary number, and it's got a little tail on it to kind of show you what it is. So the way you write it in math is like this. So I, and then the number stays in the square root. So it's I square root of 1. And then what's the square root of 1? 1. So it's just plus or minus 1i, which is the same thing as saying plus or minus I. Right? So the answer is x equals plus or minus I. So let me go back to, and that's why. So I'm showing you the reason. If you need to go back and look at that, you can check my video later, and you can go back. But now look at the answers here. It is x plus I and x minus I. That's why it is that. So there's our factors. So I took x squared plus 1 and I solved it out and got positive I and negative I. So we actually still have 3 roots. They wrote plus or minus I, but you could say the 3 roots are I, negative I, and 3. Now, the deal with imaginary roots are they don't show up right on the graph. So on the graph, we're only going to see the real roots. So the number 3, that's the one that's going to show up on the graph. The 2 imaginary roots that just happened here do not show up on the graph. So in A, everything worked nicely. We got 3 real numbers. It showed up on the graph. Everything's great. In B, we got 2 imaginary numbers. So that's why on the graph, we only saw 1. So if we go to B on Desmos, x to the third minus 3x squared plus x minus 3. Then notice what we see is it only crosses once, but it's still a cubic function. So we still know it's a cubic. It only crosses the x-axis one time. The other 2 roots are imaginary. So if you're only seeing, remember that a cubic function technically will have the 3 roots. Well, if it only has 1, if it's only crossing at 1, then you know your other 2 are imaginary. They're not showing up on the graph. Okay, so that's going to be the toughest one. You should see more like A, but B is the hardest as far as we go. So remember, we're canceling out C and D. For example, we're canceling out C and D here. For example, 2. So is everybody back? We're going to clear this. Well, yeah, let's clear all our drawings. We're going to move to page 2, right? Example 3. Everybody moving on to page 2. Okay, so in page 2, this is called, it says using the given factor, find all remaining factors, and then determine all roots of the function, and then sketch a graph. All right, so a factor means when you plug that number in, it is going to make the equation equal 0. So this is where the synthetic division I showed you yesterday comes in handy. And again, we're only going to do A and B on this sheet, so that's good. So this is where the synthetic division I showed you yesterday is going to come in perfectly. So the factor is x plus 3. So if we're doing synthetic division, which is what we're going to do here, then the number we put in the box is the opposite. It's negative 3. And the reason we put a negative 3 in the box is because we remember x plus 3 equals 0. So that means x really equals negative 3. Then we're going to put our coefficients. So we have a 1 x to the third. We have a positive 4, a positive 1, and a negative 6. So there's our 4 coefficients. And we make a space, and we bring the first number down. So we bring the 1 down below the line. Once we bring the first number down, what is the next step in synthetic division? After we bring the first number down, what would we do? Yeah, we're going to multiply. Anytime a number gets below the line, we're going to multiply by the number in the box. So 1 times negative 3 is negative 3. And notice we put that in this next open space. And then we're going to add. So positive 4 and negative 3, if we add it together, we get 1. So again, we get to multiply. 1 times negative 3 is negative 3. Positive 1 plus negative 3 is negative 2. Multiply negative 3 times negative 2 is a positive 6. And then add negative 6 and positive 6 is 0. So notice we get a remainder of 0. We should always get a remainder of 0 if we're doing the factor theorem. So now we started with x to the third, right? We start with 1x to the third. So our answer should be 1x to the second. And then there's 1x. And then there's negative 2. And notice there's no remainder. So here's what we're saying now. We're making this into a very, we're going way back now to math 1. And we're saying factor this. What two numbers? So here's what I would. Here's the question I would ask you, and I'll put it in the chat. What two numbers multiply to give me -2 and add to give me +1? And you say that's 2 and -1, right? So you're going to say x plus 2 and x minus 1. That's how we get our factors. So now we already knew that x plus 3 was a factor because we used it to do synthetic division. Now we also know that x plus 2 is a factor and x minus 1 is a factor, which means if x plus 3 is a factor, one of the roots is -3. If x plus 2 is a factor, one of the roots is -2. If x minus 1 is a factor, one of the roots is +1. Now, the roots are -3, -2, and +1. So let's look at those on the graph. So let's go to Desmos. X to the third plus 4x squared plus x minus 6. X to the third plus 4x squared plus x minus 6. Look at where it crosses the x-axis, -3, -2, and +1. And if we go back, -3, -2, +1, we graph this, -3, -2, +1. Any question for part A? In example 3. Okay, we're going to do part B, and then once we finish part B, we're going to mark off the rest. Remember, we're not doing C, D, or E. We're going to do part B. Once we finish that, I'm going to tell you which questions I would like for you to do from the homework, because we're not going to do all those questions either. But I'll tell you which questions you need to do for your homework, and then after that, we'll be done for today, unless you have any specific questions, and I'll stay on here for that. So let's move down to part B. Part B. The factor is, I'm gonna write on here again if that works for y'all. The factor is x minus 2. So that means that we are going to put a +2 in the box. Remember, you put the opposite number in the box. We are going to write our coefficients. So we have a 1, a -5, a 2, and an 8. So that's where these numbers come from. 1, -5, 2, and 8. Those are our coefficients. We're going to bring the first number down. So we're going to bring the 1 down below the line. And we're going to now multiply by the number in the box. So 1 times 2 is 2. -5 plus 2 is -3. -3 times 2 is -6. 2 plus -6 is -4. -4 times 2 is -8. 8 plus -8 is 0. We started with x to the third, so our answer is going to go 1 degree less. So we have 1x squared, we have -3x, then we have -4. So again, my question that I'm asking is, what two numbers multiply to give me -4 and add to give me -3? And you say -4 and 1. So we say x minus 4 and x plus 1. Those are our factors that go with x minus 2. Oh, where did I get the -6? Okay. So let me start over. So I brought the 1 down. 1 times 2 is 2, right? Then I got to add. -5 plus 2 is down -3. Then I take that number that's below the line and I multiply by the box. So -3 times 2 is -6. And then I add. 2 plus -6 is -4. And then again, I would multiply by the number in the box. -4 times 2 is -8. Then when I add at the end, I get 0. Does that answer that question? Awesome. All right. So the factors are x minus 2, x minus 4, and x plus 1. So that means x minus 2 means the root is 2. X minus 4 means the root is 4. X plus 1 means the root is -1. So that means it should cross at 2. It should cross at 4. it should cross at -1. If you're having trouble graphing these, Desmos, that's where I'm graphing them. That's where you would graph them if you're taking a test. That's where you would graph them on the different exams. If you're doing it in the next math class, if you're doing any of that, then we're going to use there. Again, x to the third minus 5x squared plus 2x plus 8. X to the third minus 5x squared plus 2x plus 8. Is the graph, and if you notice, you see that it crosses at -1, 2, and 4. Okay, so that's A and B. We're going to mark those off. We're done with those. And we're marking off C, D, and E. We're not going to deal with some of the imaginary ones as they are not going to test you on that. They're only looking at A and B. So example 2, A and B, and example 3, we did A and B. Okay. So I'm going to take you back. So those are all the notes that we needed from today, and I'm going to kind of end this with showing you the homework. So I'm going to share the homework questions that we had. It says without using a calculator, but there's no reason in this case that we would not use a calculator. So I would say I would take out the word without, and I would say using a calculator. I would specifically say using Desmos if you're able to, since you're already on here. You're going to work with these. You're going to find the graph. You can find where it crosses the x-axis. That will give you the roots. Then you can find the factors, and you can go through. In this one, you wouldn't have to factor by grouping. You would just say, what's the GCF of these two? Take it out, and then write what's left. In this one, this is a difference of squares. So again, you can work backwards. Just graph it, write the roots, write the factors, and then write what's left. I'll go back in example B in just a second. In number 3, this is your factoring by grouping. So you want to circle those and circle those. Okay. Number 4 is what we just did. And I think that's it. So what I would like for you to do today is for the homework questions, if we can just do 1, 2, 3, and 4, we can take page 2 if you have your packet and just throw it away. Okay, everybody good with that? All right, so if you just take page 2 and throw it away. Also, I'm gonna ask you another question when we finish, but we're gonna do 1, 2, 3, and 4. So let me go back to Andrew's question for example B. Let me go back. For example B, how did I get x minus 4 and x plus 1? So I did the synthetic division. So 1 times 2 was 2, and then I added -3 times 2 is -6. I added -4 times 2 is -8. I started with x to the third, so that means I've got x squared, -3x, because I'm going down a power each time, and -4. Basically, I'm factoring what two numbers multiply to give me -4 and add to give me -3. That's -4 and +1. So that's how I get the x minus 4 and x plus 1 in there as my factors. I could also have graphed this, found the roots, and then worked backwards. If the root is 2, x minus 2 is a factor. If the root is 4, x minus 4 is a factor. And if the root is -1, x plus 1 is a factor also. Okay, so let's go. Let's stop this. Let me ask you one question. I'm going to take everybody. So you're unmuted. It's kind of crazy, but in general, actually, let me mute you back, because so that way I don't. Okay, in general, what I need to ask you as we go through is, let me see if I can post this. I was wanting to add a question, but it wasn't letting me. And then I could ask you really simply. Let's see if I can do this. So I want to find out, so basically this packet that I gave you and the information I gave you, this ends as of this ends as of March 30th. Well, clearly we're going a lot further than that. So we have a new one. I've already wrote the new information from March 31st through April 9th, but I'm going to have to ask you. So you're going to have two choices here. I'm making a poll, sorry. And it's going to help me answer this. Okay. So let's see if I can go back now and see the poll. Yep, launch polling. All right. So my question for you is basically, do you want a hard copy or not? And then I can see. So what I mean by that is we're actually looking at, so I can print off all these worksheets and you can put it in your notebook and you can have it, or do you just want it to be scanned where you know, where all you're getting is you would have to print off at home or you would have to write on your own paper. And I can definitely, I see a lot of yeses. I can definitely make a hard copy. I think for math, to do the guided notes and the equations, that it's kind of gonna, that it's pretty tough. If you had your own printer, I guess it would be fine. But basically, the school was, if you had internet access, they were not going to print you off a new packet. And I kind of talked to Mr. Clark and I said, well, I think honestly, we still need a packet because they were still expect you to do the work, but without the hard copy. And I said, for math, I think that's going to be kind of hard. So there's a few of you that haven't put your thing on there, but just make sure. So what I was thinking was right, I think. So I can give you a couple updates. So obviously we're going to be doing these Zoom meetings all the way through May 15th. So that is right now how long school's closed. If we are able to open on May 18th, we would go for a week or so. We'll see how that goes. We won't know obviously until sometime in April. You guys have done well so far. So if you'll keep, I know each day is a new day, but if you'll keep logging in and doing this daily, then it's really going to help you. Can I show for the attendance? Okay, so basically, if you go to the Canvas page, you're logged in. So let me share the screen one more time. I can share my screen. All right, so like if I go to, if you just go like, let's see, like if you're on your dashboard and your classes pop up, then you are actually logged into, yes, you need to put it in your notebooks, because here's the thing, a lot of you are taking the AP stats and some of this stuff is going to come in again. And if you're not taking AP stats, it's going to be in pre-calc, it's going to be in math 4, it's going to be in all of this. So when you go to the math 3 honors, once you click on the site, if you're on the page, you're logged in. So like once you're on the page, it means you logged in. You may just want to click on the announcement to make sure you're logged in, but then I myself will be able to see that you've done that. But once you're on my site, it will show that you've logged in. So make sure, like as soon as this meeting ends, if you are in this meeting, make sure you go to the Canvas site and just log in real quick, just to make sure that you're on there. Okay. All right, guys. Thanks for being here, and I'll send you the stuff again for tomorrow, and we'll keep going strong. And I appreciate it. Does anybody? I've unmuted.
Some beaches they've closed. You can't even get on the beach.
Yeah.
I've unmuted everybody. Who has a? I have a question.
Yeah. What if you haven't logged out in like a week?
Yeah, that's gonna actually. We're not starting the attendance part that they wanted us to start is not going to start until it's going to start on Monday, next Monday. So I was giving you like kind of a preview of what they're asking us to do.
All right.
So I'm not checking I am making a log of everybody that was in Zoom video because it gives me that, but we're not having to click the attendance until next Monday is when they want us to do that. Anybody else? All right, we'll see y'all later. I'm gonna end the meeting.